Andrew said I had to tell you everything about CCTN, give you a complete update on all the newest findings from the research community, and something else I can't remember. And then he said you have about 22 minutes to do that. So you're going to have to listen quickly. What I'm actually going to do is focus on the clinical trials that are ongoing where they're at. Okay, well, that's a pretty picture. That's gone. These are the 24 institutions in Ontario involved in the clinical trial network. The important piece of information about that is that it ranges from the major academic centers to the community hospitals. And I don't think there's another 5 or 10 out there that are not part of this. And I think that's actually quite a great achievement in the sense that given the size of the patient population with type 1 diabetes and the interest in general, to be able to get that many people working together on the same page to try to accomplish something is absolutely terrific, and it puts JDRF ahead of the curve, and it puts type 1 diabetes at the top. The only two diseases where there's more activity in clinical translation or clinical trials are cancer and heart disease. And that's because they have many people with cancer and heart disease and major funding. And for any other disease, and by the way, you probably don't think about this, but there's a lot of people with type 2 diabetes in Canada. You have not heard about a type 2 diabetes clinical trial network to advance the science for all those people. And so we have a lot to be happy about in that regard. Now, we'll do this in a little bit of an orderly fashion. I said I would do it without this. I wanted to remind people what the grand scheme is for the development of artificial pancreas technology, because that's been at the heart and soul of what we're doing. So on this slide, it's the first generation, second generation, and third generation, and across the bottom of the slide is where we're making progress. So you can envision the funding decisions and the research that we're trying to encourage takes you from the top of the slide to the bottom, and the arrow across ends with a fully automated sensor hooked to a pump with an algorithm or software in the middle that has insulin plus something else like glucagon, because the combination of insulin and glucagon should be able to accomplish the task of controlling the blood sugar better and virtually eliminate the possibility for hypoglycemia. And that would be terrific. And one speaker we try to get for you tonight is a fellow named Ed Damiani, who's in Boston, and he has a single system that actually does that. It delivers both hormones to whatever the sensor is saying. He's got that in an ambulatory setting, and he's not here today speaking with you because he's doing that study to advance it through the regulatory process. Now, the bad news is it's still not the size of a cell phone. So we need all that stuff to be the size of a cell phone so kids will want to use it. And that would be great. What this is really about is extraordinarily high-quality control using the available technology today, as opposed to waiting for the technology that's going to come downstream tomorrow. You're going to hear from Bruce Perkins tomorrow. I'm going to run through the clinical trials in a tedious manner, because I use the word tedious only because there's a lot of information, but I want you to really get a sense of what is really going on. Now, Bruce created an algorithm for managing overnight basal insulin delivery in a quality fashion. And he has a system that he can individualize. He's taken 20 or 24 patients, put them on sensor, algorithm, pump in an overnight setting, and demonstrated that you can avoid hypoglycemia. And he now wants to take that study further, and I think he'll be telling you about that tomorrow. You got a preview from Paul Ferneyhough earlier that Bruce does other things. He's also doing something called a medalist study. If we have time, we'll talk about it, but I hope we'll have time with Bruce tomorrow. So you can save that. But here's a study that's actually been completed. The outcome measures that will be reported have to do with avoiding hypoglycemia, how well you keep the blood sugar in a physiologic range, and it takes this out of the static, simply treating somebody on an individual basis with a closed loop. We think this will change how the clinicians have to practice medicine in treating people better. Now, a different version of the same conceptual piece is called the nocturnal pump suspension to prevent hypoglycemia. That study originates from Stanford University and has 3 groups: Stanford, Colorado, and Irene Hramiak in London. And they're actually working with algorithms to do something similar to what I just described with Bruce. And they've done the inpatient studies with 24-hour nursing observation, and now they're doing the outpatient studies in Canada because the regulators said you can take somebody out of the hospital. They don't have to have a nurse practitioner or a physician watch them for every minute. And that's actually been working. And the Canadian site works better than the US sites and has completed its studies. And the United States studies were held up by the FDA. Health Canada has kind of been much more user-friendly. That gives Canada a leg up in putting new technology in place. And you'll see that the Enlight sensor, for example, has been approved in Canada, not yet in the States. So here's a Canadian arm of a group effort, and the Canadian arm has been the most productive of the 3 groups. And that's another nice finding for us here. The 3rd study in the artificial pancreas list is called TIME, the timing of initiation of continuous glucose monitoring in established pediatric diabetes, the so-called TIME trial led by Margaret Lawson at Children's Hospital in Ontario with collaborators in London, Hamilton, Markham, and Toronto. And she hasn't completed the study yet, but she's probably 90% enrolled and through it. And those of you who have previously heard Margaret, who have previously heard Margaret can understand why that is, because she's like wildly enthusiastic, and it's hard to be in a room with her and not sign up and do the study. You're actually going to hear more about that from one of the collaborators. Tomorrow, Susan Kirsch will be going over the TIME study with you. But I can't see. I know there's a young man in the room somewhere who's been involved with that study. You don't qualify on the youth part. Okay, you'll hear more about that tomorrow. But conceptually, what's important about that study is it's, again, current technology. And Margaret said, why can't we get our kids to use this stuff? And maybe it has something to do with how we approach initiating treatment. So at the time an adolescent gets type 1 diabetes, she has one arm of the study where people get a sensor, a pump, right at the very beginning. That's the first way they get to understand how to handle their diabetes. Another part of the group just gets a pump, and a third part gets standard treatment. No pump, no glucose sensor. And her idea was if you initiate all the technology right at the beginning, and nobody has a preconceived notion of what they might like or not like, you have a much better chance to get good compliance. And I haven't seen the data, but I'm pretty sure she's going to turn out to be right in terms of how that goes. Now, I forgot to tell you why that's important. I didn't have enough time to plant slides. But remember, at other times I've told you that if you have tight control and avoid hypoglycemia, you dramatically change the complication rate. And our obligation, we feel, is to get people treated as well as possible while we're waiting for the cure. Because when the cure sets in, we don't want to have a lot of people with complications. And the remarkable thing is we have the possibility to do this. The challenge for a country like Canada is there's no even-handed approach across the whole country to provide sensors, pumps, in terms of third party and how to go about doing it. I firmly believe that the data from this study will be able to go back to the government and say, stop fooling around. Here's a better way to do this. Give us third-party pay, fix the reimbursement system so it works and the correct people can educate. And while we're waiting for the cure, we'll at least be doing the very best that's possible to do. I think it's an extraordinarily important study. Will change everything about how people with this disease are treated in Canada. The next study is the first global effort to evaluate continuous glucose monitoring as an important adjunct to how to manage diabetes in women with type 1 who are pregnant and are going to have children. And for those of you who don't know, if you're pregnant, you risk a variety of complications if you're not well controlled. And you can be reasonably well controlled these days without the glucose sensor and without the pump, but you can be exquisitely much better controlled with it. And what we hope to be able to prove is that you have fewer babies who are born of large size, something called macrosomia, fewer complications of delivery, fewer cases of diabetes occurring in the child, and in every way possible, enhance the quality of diabetes management in pregnancy. Now, the interesting thing about that particular study, which was promulgated from a Canadian group, is that JDRF and the international community of people who are interested in pregnancy said, you know what, we should probably join that effort. And JDRFI in New York put up separate money to bring in a handful of international sites. And they are listed here. You can't read them in the back. But this study will be occurring in the UK, Spain, Italy. It says Israel, but I don't think that's quite accurate. Now, interestingly, the study in Canada includes a component in Calgary. And some of you may recall that Calgary is not located in Ontario. So we cannot use the funds from the FedDev to fund Calgary to be a part of the study. But Calgary got funded from New York because it was a valuable international site. And actually, Andrew and I were over there one day, and they're like wildly enthusiastic, have lots of women to put in the study, and that's great. So there's lots of things you could focus on about something like this, but this will be the first time this is done. We think this will change the face of how pregnant women are managed. And how good is that? Isn't that what we all want? So that will change a lot of things. The subtext is that it will give us an opportunity to study some scientific changes that occur in pregnancy. For example, it's known that in the clinical course of pregnancy in this setting, some hormones are distributed that actually increase beta cell mass. And we have investigators from a science point of view who are studying what's the stuff in the serum of a pregnant woman that tells beta cells to grow. Because if we could sort that out, we'd have another approach to handling beta cell regeneration or restoration. So we're like very excited about that. Now, the last study using technology is one that we're doing in the First Nations community. And Stuart Harris from London is leading that effort. And this is a study in First Nations women who actually have gestational diabetes, not type 1. And that's type 2 diabetes. And the study is to go into the community. In this case, he's got 3 communities, and examine the quality of care, measure everything you can, use continuous glucose monitors, not as a form of deciding treatment, but as a form of documenting how good or bad the glucose is. And the outcome of this study, we think, will define for the first time what is the real quality of care that's being delivered to this patient population, and can it be improved? In a perfect world, that will lead to a follow-on study which says, here's what you have to do to handle this properly. Now, if you just step back for a second, it turns out that in the First Nations community, there's an epidemic of type 2 diabetes, and that group of people are getting younger and younger. And they have now teenagers and women in their low 20s with type 2 diabetes who are becoming pregnant, having multiple pregnancies, and if they're in very rural places, they don't tend to get seen in a high-risk OB clinic until the 3rd trimester, when it's, for practical purposes, very difficult to do anything about. And the Canadian healthcare system is willing to take care of these people earlier, but they don't get into the healthcare system. They just get taken care of at best out in the rural area. And I shouldn't restrict that to rural, because it turns out that there's some urban versions of the same kind of issue going on there. Now, oddly enough, or maybe not oddly enough, the United States has the same problem. Little different name, Native Americans. The National Institutes of Health supports a group in Phoenix, Arizona, that takes care of this population. They're having an epidemic of type 2. And if people don't do anything about that, we're going to have yet another generation of kids with diabetes, poorly managed, and the healthcare system will click in and take care of them at a stage when everybody's got complications. So we actually, it wasn't our original desire. We didn't sit down and say, let's do a study in this population. But we had talked to a lot of people, and we found this to be compelling. Now, everything I just described to you about artificial pancreas and continuous glucose monitors and pumps, remember, we couldn't have had this conversation 18 or 24 months ago. So you wouldn't have any good examples of how to do this. And 12 or 18 months from today, we should have many examples of how to do this well. And we should have an easier time to convince healthcare delivery people how to do it better and right. And that, we think, will have a very big impact. That's the map showing you where the physical location is of those. Now, moving away from the artificial pancreas component of our program, we have a study at sick kids in Toronto led by Fareed Mahmood called Adolescent Type 1 Diabetes Cardiorenal Intervention Trial. And in this study, the question is, when you have type 1 diabetes and begin to show microalbuminuria, what is it precisely that you should do about that? And in this instance, a group effort that includes the UK, Australia, are studying adolescents and children, examining their urine, treating some with ACE inhibitors and a statin, and following them over time. A sub-study has to do with measuring what is going on without the treatment. This study has the potential to define precisely how we should treat adolescents with type 1 diabetes who have microalbuminuria. For those of you who don't know or haven't thought about it lately, clinicians often prescribe ACE inhibitors in that setting. That makes the albuminuria go away. And then when you stop the drug, it comes back. And what is not known is if you kept going, would that alter the natural progression of disease in that population? Or if it doesn't alter it, what other drug in combination would? So it has a very relevant and important finding if you happen to have an adolescent with type 1. You'd like to know the answer to that. This will hopefully define that. The interesting thing about this study, this was funded by JDRF in New York to a group in England who got partners in Australia and got a partner in Canada. And the group in Canada is outperforming the group in the UK and Australia in terms of enrolling patients, studying them, getting the follow-up data. And that is telling us something else about the Canadian system and the ability to do translational medicine, that it's very effective. We've got a very cooperative patient population, really high-quality scientists, terrific institutions. It's a good place to do clinical trials. And I'm not going to bore you with that because I know somebody's going to shout. The removal study is another international study. The Canadian component is headed by Irene Hramiak in London. The study is about using metformin, a drug used typically in patients with type 2 for insulin resistance. It says we're going to give people with type 1 metformin along with whatever else they're getting in the hopes that removing insulin resistance from that subpopulation of people with type 1 will significantly reduce the cardiovascular side effects. This enrolls people 45 years plus, and the numbers are about 20% of people with type 1 who are 47 have insulin resistance. So it'd be a good thing to treat them. That's not the standard of care. It'll take us a while to do that. This study also is enrolling people way out of proportion to its commitment. And probably this study would have failed had it not been for the Canadian component. A very interesting study is ongoing at sick kids that is looking at people with type 1, checking them for celiac disease, and identifying a subgroup who have the positive, antibodies, intestinal biopsy that confirms celiac, but who are totally asymptomatic, and asks the question, do they need to be treated or not? And if so, does that positively influence the clinical course of the diabetes or not? For those of you who don't know, it's estimated that about 6, 7, or 8% of people with type 1 diabetes have celiac disease. For the most part, asymptomatic, may not affect them in a long-term setting, but we don't know precisely what to do with that population. And for those of you who don't know, celiac is an autoimmune disease where the abnormal reaction is pathologic, just like type 1 is an autoimmune disease. And this will be actually the first study that will document sort of precisely how many people have it and what you should do about it. And then we'll have all those samples available for research studies. The next study is headed by Cheryl Clarkson at the University of Western University, I think it's called now, in London. And this study deals with, it's called the structured transition in adolescents and young adults. The bottom line to this study is adolescents who, without type 1 diabetes, have certain issues. And when they leave the pediatrician's office, typically they do not land in the hands of adult medicine endocrinologists right away. That usually coincides with a kind of rebellious moment in life when they'd rather not have the disease, and sometimes an adolescent's solution is to say, well, I don't have it, so I don't have to pay attention to food, diet, and that sort of stuff. And when they wake up 5 or 6 or 7 years later, they've already got the predilection for complications in place. In order to avoid that, we need to capture that population, not let them escape, and give them an easy path forward to get the good treatment, to maintain tight control. And this study essentially offers that possibility and provides what I would call a concierge nurse, or somebody who that individual can relate to, and if they don't show up for a clinic visit, they get called, and if they don't show up, somebody will go to the house and drag them in. But the care is no longer discontinuous. And the question is, if you do it that way and everybody gets well treated, can we avoid this 5 or 6 year period of very poor quality control? And for those of you who pay some intellectual attention to the real finer print, there's a thing called metabolic memory, and it turns out if you lose good quality control for 5 or 6 years, and then you start doing everything perfectly the next day, you don't get back to where you would have been had you just maintained it continuously. Now, I'm out of breath. I hope you're breathless. That's actually a lot of clinical trial work that we could have never had a discussion about before. Now, I do want to confess that I didn't show you any clinical trials that are going to cure type 1 diabetes. And the reason for that is that we had a very short time to implement the funding for the Canadian Clinical Trial Network, and we couldn't absorb studies that would take 2 or 3 or 4 years to get going, which some of the more innovative high-risk things were. Now, fortunately, along came a group called the WB Family Foundation, who had an interest in helping us find a cure for type 1. And what we said to them was essentially the truth. We had established the Canadian Clinical Trial Network, but the funding was restricted to Ontario, so we have not opened the door to what would be exciting studies that could begin to deal with the cure. And if they would contribute research funding and not restrict the funding to Ontario, we could go nationwide and offer an opportunity for investigators anywhere in Canada to come up with their best shot about how to cure type 1. So we put out an announcement that said, send us your applications. We're interested in pursuing a cure. You can be anywhere in Canada. And we got 10 or 15 very high quality letters of intent. We're in the process of finalizing which grants in that make sense to fund. And we're very optimistic that we'll have at least 2, possibly more than 2, clinical trials that are dealing with the potential to cure this disease, either by sophisticated state-of-the-art beta cell replacement efforts. And what I mean by that is stem cell-derived material, not simply human islet transplant, or making the autoimmune response go away, inducing immune tolerance so the autoimmune response wouldn't react. And as you all know, because you've been to this lecture before, type 1 diabetes is complicated. You need 2 things to cure it, not 1. You need to make the autoimmune response go away, and you need to restore beta cell function. The extra money that the WB Family Foundation is providing offers us the potential to fund studies beyond Ontario, bring those groups in to become part of the clinical trial network, and it permits us to go back to the community and say, now we're funding 10 or 11 studies in an area where none were occurring before. Here's the data that's coming out. Here's how we work in the international community to leverage. Here's what we're learning from a scientific point of view. And I would submit to you that all of that makes a lot of sense in terms of how we're going to cure this disease. And for those of you who heard Dr. Fernyho's lecture before, he showed you a chart that said basic science on the left and large clinical trials on the right. And in the middle, he said there's a place called the Valley of Death where nobody's doing any work. So I'm here to tell you that we're working in the Valley of Death, although that's not the fundraising mantra. We don't go and ask people, give us money so we can work the Valley of Death. What we say is, give us money to do the high-risk, innovative research that's necessary to move this along. And I, for one, think that's pretty exciting stuff. And at the moment, we're really only limited by money, not by ideas, and not by molecules. And that doesn't even take into account what we heard a couple of hours ago, where we're repositioning drugs and having, I mean, I have to repeat it because to me this was very exciting. What you heard, if you were listening to that talk, was that for the very first time, there's data that a drug can be used in the treatment of sensory neuropathy due to diabetes, and the nerves repair and normalize. That's quite different from taking pain pills to make essentially unbearable pain go away. And there's nobody in the room who doesn't know somebody with neuropathy, where they have painful nerves, because there are a zillion diseases associated with that. And although Dr. Fernyhough is working on diabetes as a model, he could also be working on side effects of cancer drugs as a model, or sensory neuropathy, which is quite disabling for people. And JDRF did that in its spare time on another day, and we could talk about that. And the neat thing is that he avoided the Valley of Death by taking a drug that was already approved for another purpose. But if we're going to cure this disease, we can't avoid the Valley of Death, and we have to just plow through it. So we're going to do that. And by the way, I think that's a really good story because it makes sense. And if I could show you a chart of 15 or 20 things that are worth doing tomorrow morning that would go down that pathway, you'd probably say, let's figure out a way to try to do it. So that's where we're positioned. A couple of other things. We're doing a project with CCTN that involves getting the community to have a standardized approach to glucose measures, whether it's in simply a glucose measuring device or a pump or a continuous glucose monitor, because we'd like to show that there's data from any study that has comparable numbers and we can compare them. And Joe Cafazzo and his group at UHN downtown are organizing that. And researchers from our group, some others, and as well as half a dozen people from industry have already expressed a willingness and interest in doing this. And this was, we took some of the money from the FedDev and said, a project like this is extremely important to the overall progress that we could make in this area. And even though it's not a clinical trial per se, it will immensely help clinical translation. Now, I use the word extending the clinical trial network because what I think is that we're on the threshold of being able to say, I told you about the WB Family Foundation cure, but the thing I want to say to you is we are now in a position to say we've actually done what we said we were going to do. You can go examine patients. We're going to have data on really thousands of people. We'll have blood samples. If somebody comes up with a diagnostic test for early disease, we can go back to the blood samples and check them and do sophisticated studies that you read about personalized medicine, ask questions about pathogenesis. I mean, we have a real up and running clinical trial platform that offers the possibility to do translation. I put up one example. We're working with the thing called the Diabetes Retinopathy Network, an NIH-sponsored study that has been in place for a decade. They've only done studies in diabetic retinopathy in the United States. We've gotten them to agree to do Canadian sites with their money. That's good. And the Canadian sites that we've organized are in Vancouver, Edmonton, and Toronto. And on another day, we'll be in a position to say part of our Canadian clinical trial network includes studies in eye disease in relation to the NIH. And we hope to build on that because there are some worthwhile things that we could be doing in that area. So we think that basically we've created the possibility to have a very compelling argument with the government for additional funds. I can't tell you how little the money is compared to what others are spending. So comparable National Institutes of Health funded trials, a typical modest manipulate the immune system trial is $6 or $7 million. A cooperative, collaborative study is $8 or $10 million. We would be having a discussion here about doing 3 or 4 trials. We'd be really slow at it. Instead, we're having a discussion about a really facile, efficient platform with lots of volunteer patients, lots of great academicians, great scientists, and we think that it's inevitable that that's going to have a major impact in Canada. We very recently got $100,000 from Lilly. Now, what's $100,000 when we're talking about millions, right? But the important thing is, in our conversations with Lilly, we said the Canadian Clinical Trial Network is going to be one of the great places on earth to train people to do clinical trials. Now, we can't cure anybody if we don't do human studies. We already have the platform in place. They're going to give us money to get started adding trainees. We didn't get money from the government to do that. We intend to go back to the next 5 drug companies and say, you don't want only Lilly to be interested in this. We want all the drug companies. If you give us 1 or 2 fellows here and there, we'll come back in 3 or 4 years and we'll have used this platform to train another dozen people that you would not otherwise have in the system. So I'm trying to whet your appetite for the future without disclosing, sort of all the details and not making you any outrageous promises. But I don't think anything that I'm offering is particularly outrageous. It's like good common sense. And I wish we had the resources so we could tell Paul, you don't have to go spend all your time writing grants. Bring your observations to us. We'll do the next phase of the clinical trials that are necessary to move that project along. And isn't that the logical thing to do? Who would disagree with that? And that's good for everybody. So, Andrew, we've got to figure out a way, well, maybe I don't have to talk to you. I'll talk to Aubrey. Aubrey, we've got to figure out a way to do that because that's going to move this in just magnificent ways. So that's my progress report on the clinical trial network. Thank you.